Electron beam machining. Electron beam machining or EBM is a non-conventional machining process which is used for machining very hard and brittle materials which cannot be machined using conventional machining processes. This process utilizes high velocity electrons striking the workpiece surface and thereby generating heat for machining purposes. Working principle. The machining process works on the principle of conversion of kinetic energy into heat energy. When a high-speed electron impinges on the workpiece surface, its kinetic energy is converted into heat energy. This heat energy is used to vaporize materials on the workpiece surface. The whole process is carried out in vacuum to avoid the collision of electrons with the particles of air and thereby losing its energy. Construction. Electron beam machine utilizes voltage in the range of 150 to 200 kV, which accelerates the electron to 50 to 80% of the speed of light, that is about 300,000 km per second. Electron gun or cathode grid. It is a cathode ray tube which generates the electrons, accelerating them at a high speed and focuses them to a single spot on the workpiece. Anode. The anode is connected to a positive bias. The electrons are pulled towards anode at very high speed and thereby the electrons produced by the cathode filament does not diverge from its path. Magnetic lenses. The magnetic lenses reduces the divergence of the beam and allows only convergent beam to pass through the deflecting coil. Thus, highly focused beam of electrons are obtained. Deflecting coil. It does not allow the beam to deflect, thus forming a high dense beam. Workpiece holding device. The workpiece is held rigidly on the workpiece holding device which can move in all three directions, that is X, Y and Z direction. Working. This is a short representation of the working of electron beam machining. When a high voltage supply is applied to a cathode filament, it generates the electron, which move towards the anode at high velocity. After passing through anode, the beam of electron is made to pass through magnetic lenses, which absorb the diverging and low energy electrons, and only converging beam of electron is made to pass through it. The deflecting coil focuses the high energy electron beam on the required spot of the workpiece surface. The high intensity electron beam impinging on the surface converts its kinetic energy into thermal energy, and the workpiece material is removed by its intense heat, thereby melting and vaporizing the workpiece surface, and the whole process is carried out in vacuum chamber.
Application of electron beam machining. Electron beam machining is used to produce very small hole about 100 micron to 2 millimeter. It is mainly used for micro machining operation on thin material. These operations include drilling, perforating, slotting and scribing, etc. It is particularly useful for machining of material of low thermal conductivity and high melting point. It is also used for machining of wire drawing dies having small cross-sectional area. Electron beam machining is used as an alternative to light optics manufacturing method in the semiconductor industry. Especially it is useful for high resolution lithography and for the manufacture of complex integration. For making fine gas or fish in space, nuclear reactor and gas turbine blades. Advantages of electron beam machining. Very hard and heat resistant material can be machined with a better surface finish. Extremely close tolerance up to 0.4 micrometer is achieved. The beam can be concentrated on very small area. It produces better surface finish. Secondary finishing operation can be neglected. No need of heat treatment before machining. Thermal distortion is least because only one pulse is required to generate hole and pulse duration are short. No effect of material hardness and tool wear because there is no physical contact between tool and workpiece. Last is the process is fast because it is entirely non-mechanical. Disadvantages of electron beam machining. As the material removal rate is very low, the machining time is too long. The equipment cost is very high. The interaction of electron beam with the workpiece surface produces hazardous X-ray. Hence, shielding is necessary. Vacuum is essentially required, so vacuum itself requires some time to be created, so that is like non-productive pump down time. Because of very low material removal rate, the process is economical for small cuts only. Very low voltage is required to accelerate the electrons.